So, now I'm well aware that what I'm about to draw is not true on this triangle. I'm just making up a scenario. Even if we had all three angles and all three sides, which we didn't, let's just say we did. I would have made this about 3.5 and made this 8. Okay. Let's just say we had all three. To find the area, you just use the angle and the sides on opposite side of that angle. So you could have done 4 times 8 sine 46 like they did, times 1/2. You could have done 1/2 4 times 3.5 sine 84, or 1/2 8 times 3.5 sine 50. Now since I made up those numbers, they won't perfectly work. But same thing from yesterday. So area formula, you need 2 sides and the angle between them. Now, like Drake already pointed out, we couldn't have used law of sines with this because we didn't have a side and angle pair. So how would we solve for the rest of that triangle? We would do so by using the law of cosines, written there, which you probably need to get in your notes. You do not have to write down all three. Much like yesterday, it's just the same formula 3 times. So really just write down one of them and we'll talk about it. This is 6.2. 6.2. As I look at our SPIs, I realize we've already done most of those. 3.4 is what we did just the other day when we moved sine and cosine around. We're using our shifts and periods and phase shift, amplitude. That's what 3.4 was. We were moving those trig equations. So, man, we're really marching through these SPIs. All right. Assuming you just wrote down the first one, you shouldn't need much more time. Again, you don't need all three. They're the same exact formula 3 times. If you remember from yesterday's area formulas, the only thing that made them different was we used this angle here, and we didn't use that side. Same thing. If you notice, angle A is the one we used, and side A is nowhere to be found. It's the little freak over here by himself. Same thing here. We use angle B, side B is the loner. Angle C, side C is the loner. Only difference. Alright, this formula is extremely straightforward. You literally are just going to be plugging things in all day. So here, hey, this looks familiar. We're going to solve this triangle using the law of cosine. Now, there's only 2 times you'll use the law of cosines. One is if you have this scenario, side, angle, side. If you have 2 sides and an angle between them, you'll need to use law of cosines. Any other combination of sides and angles you can use law of sines for. But in this one scenario, you'll have to use law of cosines because you don't have a pair, but you still have 3 pieces. So, you have to use the angle they provide for you. So therefore, which side is going to go over there by himself? Side A. Very good, from the formula. So, A squared equals B squared plus C squared, I'm punching this straight into the formula you just wrote down, minus 2BC cosine A. That's all there is to it. Then we're going to solve. So that's A squared equals 16 plus 64 is 80, minus 64 cosine 46. Here comes the problem of the day warning in several sections. The first of which was that imaginary section where I said people are just going to square this one and square this one and they're not going to FOIL it. And then a few days ago I said another one, although I don't remember what it was. I think it was radians or degrees. Problem of the day is going to be this. Several people are going to be like, oh, that's 16 cosine 46. Wrong. These 2 things are married by multiplication. You cannot subtract any one piece of that. You have to find that entire number and then subtract. 80 and 64 are not subtractable because cosine is married. I'm sticking with that analogy. Okay, so 80 minus 64 cosine 46. Let me make sure I'm in degree mode. I'm not. Make sure you're in degree mode. By the way, raise your hand if you borrowed one of my calculators yesterday. That's great if you signed it out, but I'm missing a few more than people signed out. So I came in this morning and had like 7. I know I'm a little bare on calculators anyway, but just please make sure you sign that out before you take it so that I can locate them. All right, so anyway, punch this in, bang. 35.54 is a squared. Not a, it's a squared. How do I find a? Square root. That'll be like 5.9-ish. And it says to the nearest tenth. So I guess that would just be 6. 6. If you do the law of cosines correctly, you should never need to use it more than once. Ever. Because now, what can we use to finish that triangle? Law of sines. Because we now have a side angle pair that you can set up your proportion with. You will never need the law of cosines more than once in a problem. After you use it once, if you did it correctly, you should be able to jump straight into the law of sines, which we could now do. Law sine of 46 over 6 equals sine of b over b, and then just subtract to find angle c. We'll do it real quick. So, that would be sine 46 over 6. Now, it doesn't really matter if you find a and b. However, remember, sine inverse will never give you what kind of angle? We talked about it in that time where we had two possible. Yeah, sine inverse will never give you an obtuse angle. If there was an obtuse angle in this picture, which angle would it be? C. That's the only possible one it could be, the one opposite the biggest side. Therefore, to avoid that possible error, because let's say you punch this in and it says 85 degrees, you're like, that looks pretty accurate, 85. But it might have been 95. Remember that ambiguous case thing. You don't know, your calculator may lie to you if you're looking for that. So, always look for the smallest angle possible. And then you can just subtract to find the biggest one, and you don't have to worry about running into that dilemma. So, avoid looking for the biggest angle until the very last step. So that'll be sine of b over 4. Cross multiply. Divide by 6. Now what's the last thing I'm going to have to do to find the answer here? Thank you, Drake. Whew. Come on, Steve. Play along. Inverse sine. 4 sine 46 divided by 6. I'm going to take the sine inverse of that. And my angle is 28 point, I think it's the nearest degree up top. So 29 degrees. Subtract, and what would that make our last angle? What would our calculator have told us that angle was? It would have told us it was 75 because it won't give you an obtuse angle. So, there you go, case in point. And you've solved the triangle. Questions about a step that we took there? Because, think about the unit circle, okay? Cosine of, oh, excuse me, not cosine. Sine of 30 and sine of 150 are the same thing. Sine of 45 and sine of 135 are the same thing. 60 and 120. They're like the same thing. So when you ask your calculator, what's sine inverse of this, there's technically 2 answers for everything. And it's always going to just assume you want the one in the first quadrant. That's why. So, try this one. Oh, they gave you the obtuse angle, so you don't have to worry about that problem. Solve that triangle. And if someone's feeling confident, you can work it on the board while other people work it on the paper. Confidence. All right. Joey, dang it, you earned this. Mm-hmm. Yes. B squared. Oh, it's the same exact thing as A squared, except you switch out. See, they're the same thing. It's the same exact thing. You just switch all the little A's and little B's. So it'll be A and then A over here as well. Mm-hmm. Muy bien, muy bien. I'm assuming that's right. You want to go and find the last two pieces too? All right. Excellent. Now, you're still working. That's cool. Raise your hand if you got something negative for this far right portion and immediately thought you were wrong. Oh, that's good. Not too many people. But if you got a negative, that means you're exactly right. And if you thought you were wrong, that's actually a good thing because that means you're thinking. You're looking at your numbers and you're thinking, hey, I think I see a red flag here, and that's good. If you're just mindlessly punching in numbers and have no idea whether you're right or wrong, you're just doing what I tell you to do, then you're not thinking. If you thought you were wrong, that's actually a good thing. But let's think about this. 96 degrees, second quadrant. Cosine values are negative in the second quadrant. That's why this was a negative, and that's why when you subtracted a negative, it made this bigger. That was 52, ended up being minus a negative approximately 5, and basically added 5. So that's why. Sometimes you're going to get, if you do cosine of an obtuse angle, that's fine, but it's going to give you a negative and therefore make your number bigger. Which kind of makes sense anyway, because that has to be the biggest side, so it makes sense we would need to add to that. So, very good. Very, very good. Questions about any step you see on the board, which was beautifully done. Assuming it's right. And I assume it's right. Any questions about something you see on the board? Why we plugged something in, how we knew this, how we knew that, blah, 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 blah. No? All right, then we're ready to move on. I told you there's two scenarios you'll use the law of cosines. That was one of them. The other, and I said yesterday we did not yet have the tools to solve this kind of triangle, but we do today. The other is if you have all three sides, like this. If you have all three sides of a triangle, that is the other scenario that you can use the law of cosine. Now, cosine inverse is unique in the first and second quadrant, so there's no restrictions on which angles you can plug into that. So you don't have to worry about that same thing you have with the law of sines about it giving you misleading information. But just to play it safe, I always like to just look for the smallest angles first. It's just kind of my rule of thumb for trigonometry. So, which angle should we look for? We're going to look for the smallest one. Angle A. And everything's going to go the same way. If we're looking for angle A, that means we're going to use cosine A. And which side's going to be over here all by his lonesome? Side A. So, A squared equals B squared plus C squared. Now let me stop for a second. What's something I can conclude about angles B and C? They're going to be the same. Good. Save yourself some work by making these observations. 2 times B times C. So that's 128 minus 128 again, which is not 0 because we can't subtract those. They're still bounded by multiplication. So I subtract the first 128, which gives me what, negative 92, I think? Thank you. Divide by negative 128. And how am I going to solve for A? Cosine inverse. Music to my ears. Cosine inverse of. You can pretty much just cancel the negatives, but I'll punch it in just as it is. Bam. 44 degrees, because it says round to the nearest degree. So angle A is 44. Now, at this point, normally you'll need to start the law of sines. However, you've already noticed that B and C are the same. Well, how many degrees are left for the triangle if we've used up 44 of them? 136. And if these have to add to 136 and they're the same, just divide that by 2. Thank you. 68 degrees. Or you could do the law of sines if you want to do it that way. That's fine too. And you're done. You've solved for all the missing pieces. Yes, that's exactly what we did of that fraction. Ways that you know that you've done something wrong. If cosine stands for adjacent over hypotenuse, right? And the hypotenuses always have to be the biggest side. That's what a hypotenuse is. Because of that, cosine and sine, for that matter, always have to be less than 1. This fraction is less than 1. If you ever get something like 128 over 92, something greater than 1, you've done something wrong. Because if you try to take cosine inverse of that, it's going to tell you error. Because it can't do a number greater than 1. So, if you ever find that your fraction is greater than 1, whether it be positive or negative, you need to go back and find a possible error. And if I had to guess, I'm guessing the error is you subtracted right here. But, so just know, it's going to mean you made a arithmetic error somewhere previously. Questions on that problem? All right. In that case, try this one. Try this one. And I'll just work it up here on the board and we'll compare notes when we're done. Now, if you want your work to look the same as mine, it doesn't have to. But if you want it to, you should know I'm going to start out looking for angle C. Again, you don't have to do that, but if you want your work to look the same as mine after I unfreeze this in a minute, you'll want to start out looking for angle C. Although we should get the same answers regardless. Here's the angle C that I got. If that in any way looks different than your work or answer, raise your hand. I'd be more than happy to come take a look at that for you. If not, then let's finish this problem up. Looking for angle B. So it would be 3 sine 26 over 3 equals sine of B over 4. Cross multiply. Divide both 3. And take the sign inverse. That is going to be 4 sine 26 divided by 3. Sine inverse. 35 6 degrees. 36. 26. Add and subtract. 118-ish. Touche. Touche. Yes, it would. If you have any questions about something you see, please ask. Nope. Well, alright then. Let's see. Solve each triangle. These are the exact same as ones we just did, except there's no picture. You're going to have to kind of figure out what pieces. You can either draw the triangle, or I don't think they give you any curveballs where you don't actually need the law of cosines. But before we go any further, please look at 21 and tell me what the answer is without even punching that in the calculator. Thank you. If you remember, equilateral triangles are also equiangular from geometry. Therefore, they are 60 degrees all the way across. So that's a neat little thing to remember. That can save you some work today. Take a look. If there's one on the board that you think looks different than the others and you may like to see it work, raise your hand and tell me. Or I'll at least set it up. 17, sure. I always like to start out looking for the two smallest angles, so I'm going to look for angle A. So that would be side A equals side B plus side C, both squared, minus 2B. Yeah, that's exactly it. Exactly. Well, all right then. I'll stop. Other questions that somebody'd like to see at least set up? I can set these things up, no problem. Oh, I think we did this part yesterday, so I'm just going to get rid of those. Did we do it yesterday? Oh, everybody's like, oh yeah, we did this. Let me take a look. Write down the right-hand portion, and I'll take a gander at the left-hand portion. Sure. $34 and $38. Oh, barnacles. Way too easy. There you go. It's 12 problems, Josh. 12.